Hello, I'm Caris Redman-White. I started my career as a vet and I'm currently researching epidemiology of antimicrobial resistance, or AMR, for my PhD at the University of Edinburgh. I'm particularly interested in One Health, which is the interactions between the health of humans, other animals, and the environment, and AMR has been described as the quintessential One Health challenge. My focus is specifically on antibiotics, the antimicrobials used to treat bacterial infections, and that's what I'll be talking about today. We need antibiotics to remain effective for many aspects of modern medicine, not just for treating infectious disease, but, for example, to allow us to perform surgeries and to make childbirth safer. We also need them for animal health, including food-producing animals, both terrestrial livestock and aquaculture. At any time we use antibiotics, the bacteria have a chance to develop resistance to those drugs. So to minimize AMR, prudent antimicrobial use is vital. There's room for improvement in our antimicrobial use in livestock to minimize AMR for sustainable farming. So for this paper, we went through a big swathe of peer-reviewed literature on predictors of AMU and AMR in farming in Europe. And where there was little or no peer-reviewed literature, we looked at government reports and industry statistics. The species we looked at were those typically farmed in the UK, which are pigs, layer and broiler hens, beef and dairy cattle, sheep, turkeys, and farmed salmon. As it turned out, most of the peer-reviewed studies were looking at pigs, dairy cattle, and broiler chickens in that order. There was not much on sheep and laying chickens, and almost nothing on farmed salmon. Some types of predictors were also more researched than others. For example, while there was a lot of evidence addressing the role of biosecurity, there was surprisingly little covering the influence of vaccination on AMU and AMR. We made a spreadsheet of all the sources, including where and when the study was conducted, what metrics we used. There are quite a few types of metrics you can use for AMU and AMR, and all the key findings. And this is available as a supplementary file for the open access publication. And then to bring everything together, we also constructed diagrams of each production system with predictors mapped onto each point in the production cycle and indicators for how strong the evidence was. If you're looking for a visual summary of predictors for each livestock type, I would suggest having a look. They're all available open access online. In terms of the key insights, predictors of low AMU and low AMR fell broadly into three categories. The first category was antimicrobial stewardship, knowledge, and behavioural factors. This was decisions made by farmers and veterinarians, for instance, in a mild case of disease, choosing whether to give supportive treatment only or whether to treat with antibiotics. From a farmer or vet's point of view, it's really tempting to reach immediately for broad-spectrum antibiotics out of concern for an animal's health, but a lot of the time it's not actually necessary or even beneficial. So using diagnostics appropriately can help decide what antibiotics are needed, if any. And in a lot of cases, for example, mastitis in dairy cows, there are treatment algorithms or protocols that allow you to assess whether antibiotics are needed or whether supportive treatment, in the case of dairy cows, simply anti-inflammatory pain relief and warm compresses are likely to be sufficient. The second category was herd health and preventative health practices. One of the key predictors in this category was hygiene and biosecurity. So this includes external biosecurity, not letting disease onto the farm, for example, having restrictions on visitors, and also internal biosecurity, which is avoiding disease spread between animals on the farm. This includes practices like avoiding mixing of animal groups and planning the day's tasks so that you work with the youngest, most vulnerable animals first before moving on to older age groups. The final category of predictors covered broader cultural, regulatory, and socioeconomic influences. That includes things like the economic environment in which the farmer is operating. A lot of concerns raised by farmers were that reducing antibiotic use would cause more disease and more production loss, or that biosecurity changes would be too expensive to implement. The good news on that is that several studies showed that when farm-specific AMU reduction plans were developed in collaboration with the farmers, they were effective in reducing AMU without producing any negative impacts on the farm's productivity. Demand-side influences also fall into this category. So, for example, large-scale buyers like supermarkets may impose restrictions on AMU, or farmers may join assurance schemes. So, for example, gaining organic accreditation, which has stricter requirements for AMU than standard regulations do. Of course, whether people can and will pay for organic products will vary depending on the economic situation and public perception of different types of farming. These will also vary between Europe and other regions because practices for conventional farming and definitions of organic farming vary quite significantly across the world. So my two take-home messages from this publication are firstly that we have some big gaps in our knowledge, covering some key farm species as well as important practices like vaccination. But what we do know is that in general, farms have lower AMU and AMR when you have firstly good knowledge and practice of antimicrobial stewardship, secondly good herd health and preventative healthcare, particularly biosecurity, and finally when the economic, regulatory and social norms are conducive to reducing AMU. Thank you for listening, and please do check out the paper which is available with open access on Frontiers in Antibiotics.